In this video, we're going to be looking at how to determine really quickly whether a cubic graph is increasing or decreasing. Although I've got the graph next to us here, I want you to imagine that you didn't have it at all and that you've just been given this equation and you ask, where is this cubic graph increasing or decreasing? What you can do in seconds is see in front of the x cubed is a positive, and so you know that the graph is roughly speaking going to look like this. And if I ask you where's this graph decreasing, you can see in seconds again that it's decreasing between the turning points. And so the really quick way to work this out, where's a graph decreasing, is just to work out the derivative, because that will give us the, when I make it equal to 0, I'll get the stationary points, and then I can look at my quick little visual to see, okay, decreasing was in between them. And so mathematically, how do I work out where a cubic graph is decreasing? It's just, I do the derivative, and I make it less than 0. In other words, where is the gradient going downhill? Because when I do the derivative, that gives me the gradient of the tangent. And so if I'm looking where it's decreasing, it's where the tangent would be have a negative gradient. And so that's all that you're doing. Where is it decreasing? It's where the derivative is less than 0. I'm going to divide everything by 3 just to make this example a little bit easier. I'm going to factorize this. It's very tempting to just say x is 3, x is minus 1, and both of them will just be less than 0. But for teaching you a little bit about inequalities in this lesson as well, we know the answer will be 3 and minus 1. So what I would encourage you is put that on a number line. So whenever I see inequalities, I do a number line. I think of this as a parabola and it's happy, so I draw a rough picture of a happy parabola. I'm looking where the stuff is less than 0, in other words below the line, and so to write my final answer, it's just in between these two numbers. You could also, and again you've got this actual graph to anchor yourself on, but you could have, when you worked out the two x turning point values, minus 1 which must have been on this side and 3 which must have been on this side, then you could have worked out that it's just visually happening between there, and so you write your x between there. And so that's just a lovely quick way to get going.